Okay, so there's 54 points in the free response section. Every problem has 9 points to it. Okay, so you take the problem and you just work it out in the space they have provided. Okay, so you just number it and put the letter down, and then you just start showing your work. Okay, so number 1, it says, let the curve be defined as x squared plus 4x y plus y squared equals 13. Find the equation of the line tangent to the curve at the point 2, 1. So if we're talking tangent, we need a tangent, we need a what? A slope. So if we're finding the slope, we're doing the derivative. Okay, so how do we find the derivative of this? So if you show you're finding the derivative, it is 2x plus 4x dy dx plus y times 4, which is 4y as you said, plus 2y squared, or 2y, I mean, dy dx equals 0. Okay, then what would you do?
Get all the dy dx on their own side?
Yep, dy dx you have to solve for. So 4x dy dx plus 2y dy dx equals negative 2x minus 4y. So dy dx would equal 4x plus 2y. Oh, that's times. So then we divide by 4x plus 2y. So dy dx equals negative 2x minus 4y over 4x plus 2y. And then we're going to plug the point 2, 1 into there. So we're going to get negative 4 minus 4 over 8 plus 2, which is negative 8 over 10, which is negative 4/5. That's your slope. That's your slope. This is your point. And they want the line equation of the line tangent to the curve. So you put it in point slope form. So y minus y1 equals your slope times x minus x1. So y minus 1 equals negative 4/5 x plus 8/5, and add 1. So y equals negative 4/5 x plus 13/5. So it'd be 1 point for this, 1 point for finding your slope, and 1 point for knowing you need to take the derivative of it, basically. Those would be 3 points for that problem. Okay? So that's how that part would be graded. Now, here's a big old something I didn't know the other day. Find the equation of the line normal to that. So what does normal mean? Perpendicular. So for B, and I'm going to go over here because I ran out of room. So for B, we have to go perpendicular. So you need to know the slope equals positive 5/4. Now, if you know that, you already get a point for that, just because that's knowing the definition of normal. Okay, then you're going to put it in the equation of y minus 2 equals 5/4 times x minus 1. So y minus 2 equals 5/4 x minus 5/4. And if we add 2, 2 is the same as 8/4. So y equals 5/4 x plus 3/4. There would be a point for that. So part B would probably only have 2 points involved, because not every problem, every part has the same amount of points. Okay? Then part C, it says find the second derivative at 2, 1. So we know the first derivative, dy dx, equals negative 2x minus 4y over 4x plus 2y. So the second derivative would equal, then just take the derivative of that. So what rule do we use? Quotient rule. 4x plus 2y times the first derivative of the top here.
Is it not the first derivative of the bottom first?
No, it's
okay.
the bottom times the first derivative of the top minus the top minus first times the first derivative of the bottom over the first derivative of the bottom squared. Oh, you know what we could do to make this easier? This should be negative x minus 2y over 2x plus y. Just divide everything by 2 right away. So the second derivative is 2x plus y times the first derivative of the top, which is negative 1 minus 2 dy dx minus the what? The top times the first derivative of the bottom, which is 2 plus dy dx over the bottom squared. 2x plus y quantity squared. So dy dx, we know, okay, dy dx we know is this. So we could plug that in right now, or we could FOIL. I don't know what the best way of doing this is.
Just plug in all the x's and y's like it is. Let the calculator figure that out. And simplify it.
No. This is the non-calculator part.
It says a graphing calculator is required for some problems.
Oh, okay, so this is the graphing calculator part. Okay. So it says you're supposed to do this at the point, find the second derivative at 2, 1. So you can start plugging in the number, I guess, the numbers at 2, 1. So the first derivative at 2, 1, so dy dx at 2, 1 is negative 2 minus 2, which is negative 4 over 2 plus, or 4 plus 1 is 5. So dy dx is negative 4/5. And then you plug 2, 1 in everywhere. So you get 4 plus 1 times 1 minus 2 times negative 4/5 plus 2 plus 2 times 2 plus negative 4/5 all over 4 plus 1 squared. And you just do the math, and Miles is just flying through the math right now for us.
Absolutely.
So this is like 13 plus 24/5 over 25. I'm just trying to do this in my head really quick. 65 plus 24 over 5 over 25 is 89 over 5, 89 1/25. What'd you get?
I got 47 1/25, so I'd probably type something in.
I
wrong.
got 39 1/25.
39 1/25. And I was just doing this in my head really quick, but yeah. So that's the process of doing it. I don't know what the exact right answer is. I'm not so worried about that. You got to know the process. Okay. The second one. All right. Let f of x equals the integral from x to that over the closed interval of that. Approximate the function using 6 inscribed trapezoids. So you got to use a trapezoidal rule to find the volume, basically the volume of that. So you're going from 0 to 2 pi in 6. So you're going from 0 to pi over 6. And then from pi over 6 to pi over 3. And then from pi over 3 to pi over 2. And then from pi over 2 to 4 pi over 3. Then 4 pi over 3 to 5 pi over 6. And, oh, no, I'm doing this wrong, aren't I? Over 2 pi. So it's every pi over 3. So 0 to pi over 3, pi over 3 to 2 pi over 3, 2 pi over 3 to pi, pi to 4 pi over 3, 4 pi over 3 to 5 pi over 3, 5 pi over 3 to 2 pi. Okay. So, a trapezoid, so let's imagine it's just like that, okay? So on this end of the trap, the width would be pi over 3, and the height on this side is if you put 0 in, and the height on this side is if you put pi over 3 in, okay? So 2 pi times 0 is 0, so it'd be 0 on this side. And if we put pi over 3, the sine of 2 pi over 3 is square root of 3 over 2 plus pi over 3 squared. Oh, this is just ugly. This is just ugly. That would be, it is a lot of writing for this one. So the distance here, the height here is, yeah, the sine of 2 pi over 3, which is square root of 3 over 2 plus pi squared, which is pi squared over 9. So that's the width. So you take 1/2 times this times the sum of those two plus, and then you just keep going through here. And there's a lot of writing to that. Okay? Problem is we only have so much time to take this.
Yeah,
So
it's so much quicker. That's not what
if you kind of show what you're doing a little bit and then just drop it, you can get some points on that. This one I don't think is so bad because the first derivative of an integral is the second fundamental theorem of calculus. So if you take the first derivative of the integral, you're back to here. So it's the sine of 2x plus x squared if you put x in, and then at 2 pi is just the sine of 4 pi plus 2 pi squared, and the sine at 4 pi is 0, So 2 pi squared is 4 pi squared. Part 2, part B. Let me make sure I'm right on that, but I'm 99% sure I'm right. So if I go back to here, practice test B, if I go here, practice test B, jump down to problem number 2. Where are we at? 3, 2. Yeah, A, this is all the work of that.
Awesome.
Yeah, that's really ugly. That's really ugly. But B was a really simple problem. As I said, 4 pi squared. Okay. And then C. So B would be one we might need to just kind of write some stuff out, skip over it, and if you have enough time, answer it. If you don't, you don't. When you see average value of a function, okay, you always are taking 1 over this minus this, 2 pi minus 0 for the integral, and it's the average value of the first derivative of that. So if you're taking the integral of the first derivative, you just put that down. So it would just be the sine of 2 times pi plus pi squared for the average value. Okay, so 1 over 2 pi, the sine of 2 pi is 0 plus pi squared. So you're going to get pi squared over 2 pi. A pi cancels out of each, and you should get pi over 2. Okay? And which is that? Ooh, what did I do wrong? Find the average value. The average value is 13.106. Find the average value is the first derivative of that. They say take that. Thus, for f of x, the average value is that. I don't see why. From 0 to 2 pi. Oh. From 0 to 2 pi, the first derivative of the function of pi should plug in. Okay. I'm not 100% sure. Okay, 3. Let f be the function defined by f of x equals 4 minus x squared, the average value of the function. When we're working with average value of the function, you write the integral from wherever to wherever, 0 to 4, so it's 1 over 4 minus 0, the integral from 0 to 4 of 4x minus x squared. Okay, so when you see average value, you got to think integral, and you write 1 over the high minus the low. Okay, so if we integrate this, and this is the non-calculator part without any use of calculator, it's 1/4 of the integral from 0 to 4. Well, we're taking the integral. 1/4 of 2x squared minus 1/3 x cubed from 0 to 4. And so we plug in the 4 and we plug in the 0. What's plugging in the 0 going to give for us? 0. So it's the mainly of plugging in the 4. So it's 1/4 of, if we plug in the 4, it's 2 times 16 minus 1/3 of 64 minus 0. And you should show the 0 at least once. So 2 times 16 is 32. So it's 1/4 of 32 minus 64 thirds. Take 1/4 of that. It's 8 minus 16 thirds. And 8 is 24 thirds.
So we don't have to integrate it before we plug in the x.
Minus 16 thirds. We did integrate it.
We did.
So that's 2x squared minus 1/3 x cubed. We integrated right there. Then we
I
plug.
have to antiderivative it.
That's the integral is an antiderivative. I don't know what you're asking, Miles.
Never mind. Oh, sorry, I didn't even see the original function. I just saw you wrote that down first. I
Okay.
Didn't realize you already did it. My bad.
So it should be 8 thirds in the end, right? Okay. All right, so that's the average value. Let R be the region bounded by the graph. Oh, quit it. Let R be the region bounded by the graph and the x-axis. So if you think about this, this is a parabola of some sort. That's kind of an upside down parabola. Okay, just saying it's going to be some sort because it's a negative x squared. So you're bounded by this and you want to find this area here. Okay, so if you need to find an area, what's the top curve going to be? This, right? And the bottom curve is going to be the x-axis, which is 0. So you have to find the integral of 4x minus x squared, basically minus 0. But you have to find the biggest thing is finding this endpoint and this endpoint. What are those two endpoints going to be? When the function hits the x-axis, those are going to be the x-intercepts. How do I find the x-intercepts of these? Set it equal to 0. So 4x minus x squared equals 0. Factor out an x. 4 minus x equals 0. So it's 0 and 4 are the two x-intercepts, right? So if 0 and 4 are the two x-intercepts, and we integrate this, we integrate it to be what we had last time, 2x squared minus 1/3 x cubed from 0 to 4. And so basically, if we plug this in, we get 32 minus 64 thirds minus 0, which is 96 thirds minus 64 thirds, which is 32 thirds. That should be the area under the curve. If we're wrapping this around the x-axis, do you remember our formula for doing that? If we wrap this around the x-axis,
Pi times the integral of.
pi r squared, right? The integral, yeah. Yeah. So it's the integral from 0 to 4 of pi, the radius squared, which is 4x minus x squared squared dx. So it's pi, the integral of, if we square this out, it would be 16x squared minus outers and inners is 4x cubed minus 4x cubed, so it'd be 8x cubed plus x to the 4th dx. So if we integrate it, it'd be 16 thirds x to the 3rd minus 2x to the 4th plus 1/5 x to the 5th from 0 to 4. And again, with it being 0, that makes it easier. I won't call it easy. So it's pi times 16 thirds times 4 cubed minus 2 times 4 to the 4th plus 1/5 times 4 to the 5th. And if you can't do that math without a calculator, then you just stop there, get the points that you got, and go on. But you've shown probably 2 of the points, like this has 4 parts to it, and if it's 9 points, you've probably gotten at least a point out of that, which is important. Okay? Because without a calculator, that would be really hard to get those numbers. 4 to the 3rd, is 64. 4 to the 4th is 256. 4 to the 5th is 1024, I think. I mean, it just...
Memorized?
What?
You have those memorized?
Kinda. I think I'm right, but yeah. So, it's time to go for lunch. Find the x and y coordinates of the absolute maximum from there to there. So we take the first derivative to find the absolute max. So let's do the absolute max here quick. So take the derivative of this, would be 4 minus 2x. So x equals 2. So our critical numbers are 0, 2, and 4. And just stick 0, 2, and 4 into the function. F of 0 gives us 0. F of 2 gives us 8 minus 4, which is 4. F of 4 gives us 16 minus 16, which is 0. So the absolute max would be the 0.24. Okay, easy peasy lemon squeezy for that one. So out of the 9 points, I bet I would have gotten 8 of the 9 on that. And 8 points on a single problem is huge.
It's way over 50%.
Yeah. So there. After lunch, we'll keep talking about this a little bit.